For this problem, we're going to examine a piecewise defined function. Here we need to consider the function g of x equals 2x plus 1 for x less than negative 1 and x minus 4 for x greater than or equal to negative 1. We want to, in part A, graph the function, in part B, list the intercepts of the function, and then in part C, evaluate the function when x is negative 5, and in the last part, evaluate the function when x is 2. So we'll start with part A by graphing the function. We'll make a little grid. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And we need to graph this function in pieces, so we'll start with the first piece. We need to graph the linear expression 2x plus 1, and when you do that for values of x that are less than negative 1. We're going to actually start at negative 1, but we know that we're not actually using it, so we're going to use an open circle when we plot that. If we put in negative 1 for x, we get 2 times negative 1 is negative 2, plus 1 is negative 1. So we'll go to the point negative 1, and put an open circle. We need to pick another value for x, but make sure it's less than negative 1, so we might try negative 2. If we put in negative 2, negative 2 times 2 is negative 4, plus 1 is negative 3. So at negative 2, we'd go down to negative 3. Here we use a dot, or filled in circle, and then we go ahead and connect those. And that's the graph of 2x plus 1 for x less than negative 1. We move on to the next piece, x minus 4. We're going to plot that for values of x that are greater than or equal to negative 1. Since we can use negative 1 here, we'll include that. Negative 1 minus 4 is negative 5. So at negative 1, we go down 1, 2, 3, 4, 5. And we are actually using it for this piece, so we use a filled in circle. We need to pick another value for x that's greater than or equal to negative 1. So we might try 0. 0 minus 4 is negative 4. So when x is 0, go 1, 2, 3, 4. And we connect our dots. And there's our graph. Move on to part B. Part B says to list the intercepts of the graph. If we look at our graph in our two pieces, we see that this piece never hits the x-axis or the y-axis, so we'll get no intercepts from this piece. But this second piece does hit the x-axis and the y-axis. It'll eventually hit the x-axis up here somewhere, and we've already seen where it crosses the y-axis. So we need to work with this second piece. That's the x minus 4. So we'll start there. Y equals x minus 4. We want to find the x-intercept. We'll go ahead and let y equal 0 and solve that equation. So 0 equals x minus 4. That yields x is equal to 4. So our x-intercept is 4. We want to find the y-intercept. We would go ahead and let x equal 0, and we actually did that when we were plotting it. So we would get y is equal to 0 minus 4, which is negative 4. So our y-intercept is negative 4. If we're going to write these as ordered pairs, the two intercepts would be 4, comma 0, and 0, negative 4. For part C, we're asked to evaluate the function when x is negative 5. It's important here that we check our domain for each of these pieces. We need to find out where negative 5 occurs. Negative 5 is less than negative 1, which means we need to use this first piece. So g of negative 5 equals 2 times negative 5 plus 1. Negative 5 times 2 is negative 10, plus 1 is negative 9. So g of negative 5 equals negative 9. Part D, we want to find g of 2. So again, we come up to our domains and find out where x is equal to 2. 2 is greater than negative 1, so we're using this second piece. So g of 2 is equal to 2 minus 4, which is equal to negative 2.